Good morning, everyone. So, as of now, we have covered a lot of things. We covered simple linear regression, we covered multiple linear regression, we have seen what is the error matrix, mean square error, we have seen how by doing the derivative we are finding out the value of the coefficients, and then also we kind of learn what is the bias, what is the variance, and what is the trade-off between them. Now, for multilinear regression, there is one more challenge is like when you have so many features, how we will do the feature selection. Now, there are some good techniques are available. One is called forward feature selection, and high level, it's like you are starting with one feature, checking what is the performance by R square value, and then adding one more feature. If the performance is improving, fine. Otherwise, go for the next feature like this way. There is another technique called backward selection. That is again, you are first taking all the features, whatever features are available for your linear regression model. You're taking everything, and then based on your p-values, you're checking whether this particular feature is statistically significant or not. If it is not statistically significant, then you are discarding that and continuing the process. Now, both the process is compute heavy, so you need to make sure that if you have so many features, it will take some time because you have to build multiple models and then you have to find out what is the best model for you. In today's class, we will show you the forward selection approach and will guide you like how it is working. As it is a compute heavy, so we will stick to some certain numbers, but for the class purpose, but I think you'll completely understand the overall concept of forward selection in the feature selections, forward stepwise feature selection process for multilinear regression. Okay, so let's start. I already have the code ready, so let me minimize it actually so that you can see my screen properly. Okay, hopefully you are able to see my screen properly. Again, I took this file from this location. So this location I can give you actually on my GitHub page. Also the file is available. So first of all, right, for any kind of machine learning work, you need to download some of the important package. So NumPy, you need pandas, and we are doing some plotting. That's why we are using Seaborn and all those things. Okay. First of all, I already have this data downloaded. So let me show what exactly inside this data. So we can see that it is actually kind of a density identification. So basically we'll try to identify the density by these parameters, these features actually. Okay. Now unnamed 0, we want to remove it because this is probably just the index column came here. So we don't want that. So we, since step this, we removed that particular column, and also we converted these two features into kg and meter for our work purpose. Okay. Also, we calculated the BMI. So we are calculating one more feature. So this is called the feature engineering. When you are creating a feature by some other features, that is called feature engineering. So this is one of the way to do the feature engineering and bring this particular new feature. Okay. We created a distribution plot here, and it is just showing that, okay, in an average, the value should be probably around 40, between 20 to 40, but there seems like there are some outliers are available. So what we did basically, we remove some of those outliers. Okay, so this command is removing those outliers and keeping the data between this range, like less than 40. Next, what we are doing, we are basically creating a correlation matrix, and then we are plotting the heat map. So heat map will look like this. Okay, by density, all these features, and we can see that whatever the derived feature we bring, that has a very high correlation with the density, so which is good thing. But again, look, the challenge or the problem is that if you just apply blindly all these features into your model, there are so many correlated features or collinearity is available. Like for example, weight and BMI, they are very much highly correlated, and there will be the collinearity also. So this is the problem. That's the reason this forward stepwise selection process is coming into picture, and there is a backward selection process is also coming into picture, but both are compute heavy. Just remember this point. Okay, so what I did basically just to check like how BMI is working. So BMI, just if I use the BMI, my kind of R square is 0.536. So whatever I do, I want to make this value better actually, right? That's basically, so basically this is kind of my initial model, my base model. Okay, I want to improve the performance of this model. Correct? That's good. Okay. So one thing is, I just gave a little bit of extra code here to present, like if you just think about these two features, then what is the linear relationships and how you can draw this kind of picture. So this is good for our own understanding. For our work purpose, what we are doing, we are only selecting these much features, and we will do the forward stepwise selection. So what does it mean? It's mean in the first path, what we will do, we will use all these features one by one and check which one is giving me the best R square on my training data. So right now we have around 250 records, and what I'm doing, I'm splitting this into two parts. Remember, train test split from this package, and then we are just using that function, splitting this data. CFAT is your data into two parts, 50-50. Half is going on train fat, half is going on test fat. Random size 0 is like every time if you run it, the same number of records and same records will go into the same data frame or same block. So number of observations in the training set, number of observation in the test set is 125, 125. Good. Up to this, very simple, very easy. I think everybody understood. Remember one thing, my main objective is to help you guys to learn. So I myself also learning. So by any chance, if you stuck anywhere, if it is not clear to me, just email me. I will definitely try to help you. Okay, that's my main goal. the way I'm learning, if I can share it, it will help others. So that's the main purpose. Okay. First piece of code, what we are doing, we are building the individual model for individual features. So that's mean first, let's consider age, weight, height, neck, chest. Each of these features I'm taking and I'm calculating the R square value. And what will happen, like when I will run this, so basically this code is doing the same thing. It's just taking the alert factors, that's mean each of these features, and create the model, fit with the train data, and then capture the best result into this variable. Okay, very simple, very easy. If you see the output, you'll be able to understand. So first model, what we did, I try to predict the density only by age, and I calculated the R square value. So this is the list of values, and from this we can see the abdomen, which is almost 6.5, so which is the best. So that's mean we identified the one feature which is our starting feature for the model. So this is the way to do it. And then if you just run it, you're getting better result compared to BMI, you're getting the better result. So at least improvement, right? Let's move on, because what we want to do, we will definitely not able to continue all these things because it will take a lot of time in this class. But our main goal is to check, we'll continue up to 5 features. So up to 5 features, we'll check what is the performance is going on. And then we'll take a decision like, okay, do I really need to keep all the 5 features, or do I need to keep only 3 features, 2 features, something like this. That's main goal. Okay. And if you want to continue, that's kind of your homework. Like you can continue this process for up to all the features, and then you can decide, okay, these are the features I need. Cool. Next step is basically, now we know that, okay, definitely we need the abdomen. So let's keep that. And then again, start the process. I don't need this line actually. Again, start the process. So it is basically again going to each of the features, but it will not consider this particular feature, and it will build the model. So basically my first model will be abdomen plus age, and it will build the model. Second model, abdomen plus weight, like this, and it will create the best model, which is abdomen plus weight. Abdomen plus weight, let's see. Yep, it's almost 734. So exactly same way we will continue. You can do it in a different way, like looping and all those things. But I just kept it very simple so that you can understand what is the main objective and how we are processing. Third step, same thing. Now we know, okay, these 2 features are critical feature for me. We know that, okay, these 2 are important by R square. Now let's again run for all the features except these 2. So basically we'll build all these models and we'll find out, okay, now this is the best combination by R square. And always remember, like when you are doing the forward selection process in the multilinear problem, R square is the parameter which you should consider. When you are doing a backward selection, that time you should consider the p-value. So this is very, very important. And when I'm saying p-value mean, like then you will consider these p-values, okay? Right now we are focusing on R square, and I believe at least you guys have idea that R square is basically 1 minus RSS divided by TSS. Residual sum of square divided by total sum of square. Okay. If you are not clear about the R square, like how R square is getting calculated, I have some other videos which I'll provide in the link so you can have a look. But ultimately the same process will continue. Okay, now the 3, so finally we'll create another models, and out of that we'll find out, okay, these are my best features. Now we know these 4 are important. Let's run one more cycle and we found, okay, these are the 5 is the best feature. So now we basically have 5 different models. One model where I have only the abdomen, and I have another model where I have 2 features. Now I have one more model where I have 3 features, 4 features, and 5 features. So total I have 5 models. Now what I will do basically, I will use those 5 models and I will do the prediction on the test data. So this piece of code, what it will do, it will basically do the testing on those models, and then it will plot on a graph R squared value versus number of predictors. So if you by chance, I'm not going line by line to this code, but again, if you have any problem, feel free to contact me, feel free to email me. As I'm repeatedly telling, I am also learning. I have work experience, so I can help you or guide you on this process. Okay, so this is showing that, okay, I have 5 models and I ran the 5 models, and obviously I have the training result and the test results. Training R score and the test R score, and then I plot into the graph. So this is the very unique way to identify, okay, which one should be the good. So now this is the important part. Hope up to this you understand the process, right? Now it's basically time to take the decision. And this is something you have to take it when you will do in the actual world problem, because up to this you can just copy paste any of the code and run it and you are done. But this is the time when you have to take a call. Okay, I will stick to only 2 features, 3 features, or something like this. So let's understand this graph very thoroughly. As the number of predictors, like, so when the number of predictor was 1, my training and test, both R square was almost same. When my number of predictors got increased, test results got training data result got increased, test data got increased, which is a good sign, very good sign. Both are increasing, very good sign. But when the number of parameters are 3, though my training data result got improved, my test data result didn't improve that much. Rather, it actually decreased. And then 4 and 5 kind of similar, both increased. So this is a critical point, like, should I stick to number 4 or something, or should I stick to number 2 or number 3 parameters? Now always remember, we always prefer a simple model. If I'm getting a good result using the 2 parameters, then I will stick to 2 parameters, 2 features. I will not add more features and I will not try to make the model complex. Instead of a complex model, we always prefer a simple model. Now, when I'm saying the complex mean, when you have many features, when you have polynomial kind of features, when you have interaction features, those are complex models actually from the linear regression point of view. But if you know that, okay, you are almost getting the better results here. So look, This is not significant after that. So we can stick to number two. Two of the features is sufficient. So that's mean what I'm trying to say, that from the forward selection process, we got this idea that if we just use these two features, probably we'll get a very decent result. Okay. So let's see what result. I think I have not printed here. So let's see. Actually, we are seeing this result here itself, right? Abdomen plus weight. So you don't need to print it, but I want to do it just for, okay, good. So almost 734. So which is here, yeah, abdomen plus weight. So R square is 734, which is a good number compared to other. And also when you do this thing, just make sure the p-values, because if the p-values are not significant, then probably you have to check this place. Also probably you have to do the backward selection in these two features also. I mean, in our case it's a two features, but suppose if you selected five features or six features, then probably you have to do the backward selection. So sometimes um, we might have to do the forward selection, then backward selection, or back start from the backward selection and then do forward selection. So this is kind of a process you have to do it for identifying the best model. Hope you like this video, and if you like it, please like and subscribe. I'll try to make such interesting videos for your learning and for my learning also. The more I practice, the more I share, it's good for me. So it's not only your benefit, it's also my benefit. That's why I prefer, like, if you get stuck anywhere, if you are not understanding, if you are new to machine learning, if you are new to data science, you can reach to me. I'll try to help as much as possible. I started my data science journey probably almost now 2 to 3 years before. So I have some work experience. So with that, I can help you. Once again, thank you so much for watching this video. I really appreciate your time. Have a nice day. Have a blessed day. Thank you all. Bye.